Hello students, welcome to the video class for the subject Basic Electrical Engineering. This subject is for first semester diploma engineering students. So in the previous class we already covered the generation of alternating EMF. So today we will cover the different terms related to this alternating EMF. Those are the amplitude, instantaneous value, cycle, time period, frequency, phase angle, phase difference, then what is DC, what is AC, difference between DC and AC. These are the things which we will cover in today's class. Okay, so let's begin with what is DC. So what is DC? The DC is the direct current and it is always flows in one direction and its magnitude remains unchanged. Okay, that means its magnitude is constant. So here you see the voltage value is V volt here, and in this waveform graph the current value is I ampere for all the time. That means when the time, see here the time is gradually increases, here also the time is increasing, but the V value is here constant, here I value is constant. So this represents a DC value. Then the next one is the what is AC. So what is AC? Let's see. AC is the alternating current. It is the one which changes both in its direction and in its magnitude. Okay, so see what is changing here. See, this is the see here this is the circuit. Here this is the resistance connected with this source. This is a closed path. When this source is applied, DC source is applied here, then I amount of current is flowing. So this here B magnitude is constant, here also I magnitude is constant. So this represents DC current. This is DC current waveform, this is DC voltage waveform. So similarly in AC, in alternating current case, see here AC voltage source is connected here. This is the resistance connected this source, and once the circuit is closed, I amount of current is flowing through this circuit. So here the waveform of the I current is like this. The AC current shown in the above circuit reverses its direction after some time, as you see in for some time this is in positive direction and for some time this is in negative direction. Okay, so this is the positive, this is the waveform in positive direction, and now this is the waveform in negative direction. Okay, these are all here symmetrical. Okay, so the AC waveform can also be other than like a sine wave that will be discussed in later part. Okay, so AC waveform is like this. That means in the positive half cycle, whatever the graph, the same thing is reverses or traverses in the reverse direction. It is like a sine wave or like a triangular wave, like a square wave. Okay, so the AC waveform may be like this also, like this. In positive half cycle, if it is like this, then in the negative half cycle it is like this. Okay, this is the alternating waveform, alternating current or voltage waveform. So the next is the next one is the how AC is different from DC. See, in case of alternating current, the magnitude and direction both change. Okay, magnitude and direction both change, but in direct current case both magnitude and direction remains constant. So in AC case, by using transformer, AC voltage can be increased or decreased as desired. Okay, this part is the something new thing for you. So just remember for now that the in case of transformer, AC voltage can be increased or decreased, but no such provision can be made in case of DC. Okay, so we can't increase or decrease the DC voltage, but we can increase or decrease the AC voltage by using transformer. So AC circuit current can be decreased by using choke or capacitor without any appreciable power loss. For decreasing DC circuit current, a resistance has to be used whose power dissipation factor is large, that is I square R is large. Okay, so for decreasing DC current, we can use resistance. Okay, because in case of resistance there is I square R loss. Okay, and it is very high, that's why for that your DC current decreases. But for decreasing AC circuit current, we can use choke or capacitor. Okay, without appreciable power loss. Here power loss occurs, but in DC, that means in AC there is no power loss, but in DC there is huge power loss. So AC can be converted into DC by using a device called it as a converter or rectification circuit. It is also named as rectifier. Okay, but DC can be converted to AC by using a inverter. Actually it is inverter, it is not chopper. Okay, it is not chopper, it is inverter. DC converted to AC by using inverter, and AC converted to DC by using rectifier circuit. Okay, chopper is not okay, inverter is correct. So AC cannot be used directly for electroplating, electrotyping, etc. But DC can be used directly for carrying out such operations. Okay, for electroplating, electrotyping, for these operations DC can be used, not AC. Okay. So simple waveform, the shape of the curve obtained by plotting the instantaneous values of voltage or current as the ordinate against time is called waveform or wave shape. Okay, so the shape of the curve obtained by plotting the instantaneous value. Instantaneous value means for a particular time the value of a voltage or current for a particular time. That means for this time, see, this is a time axis. Okay, here it is a time axis. So in this waveform, this is a time, let it is be time t1, this is the time t2, like this. So at time t1 voltage value is here, at time t2 voltage value is here, then at time t3 voltage value is here. So similarly, if for every instant if we take the value of voltage and then join those points, then we have found the wave shape. Okay, these values are the instantaneous value. So these are the example of some wave shape. The wave shape can be like this, like this, like this. Okay, now we will discuss what is cycle. What is this cycle? So see, this is our sinusoidal wave. Okay, so one complete set of positive and negative values of alternating quantity is known as cycle. So this is a positive value and this is the negative value. Okay, so one complete set of positive. So if this is a one set of positive, then this is the set of negative values of alternating quantity. So this form one cycle. So from this to this point, this represents one complete cycle. So a cycle may be specified in terms of angular measure. Okay, one complete cycle is spread over 360 degree or 2 pi radians. Okay, so then next one is the time period. What is time period? Okay, the time taken by the time taken by alternating quantity to complete one cycle. Okay, so this is our one cycle from this to this. So time taken by alternating quantity to complete one cycle is called time period t. So for example, 50 hertz alternating current has a time period of 1 by 50 second. That means to complete one complete cycle, it will take 1 by 50 second time. Okay, so this is about your time period. Then next one is the frequency. What is this frequency? The number of cycles per second is called frequency. Okay, number of cycle per second is called frequency of alternating quantity. Its unit is hertz. This is represented by Hz. Okay, so see, in the two-pole alternator, one cycle of alternating current is generated in one revolution of the rotating field. So if there were four poles, then the two cycles would have been produced in each revolution. In fact, the frequency of alternating voltage produced is a function of the speed and the number of poles of the generator. So we can write the relation connecting the above three quantity. Quantity means pole, then speed, then frequency. So f is equal to Pn by 120. Okay, this is the formula where n is equal to revolutions in rpm and p is equal to number of poles. Okay, so in simple language you can tell that the frequency is the number of cycles per second. So per second time how many cycles are going on, that is your frequency. So here for equation for frequency formula is f is equal to 1 by t. Here t is the time period. Okay, so frequency and time reciprocal is reciprocal to each other, or you can say we can write t is equal to 1 by f. Okay, this is the most important formula. Frequency, this is the relation between frequency and time period. And the next one is the amplitude. What is this amplitude? Amplitude means what? The maximum value, positive of or negative of an alternating quantity is known as its amplitude. See, if this is our sinusoidal waveform is like this. Okay, so the maximum value, positive or negative, here the maximum or peak point is this one. This is the peak, and in the negative half cycle this is our peak. This point is peak, and here this point is peak. So this is your amplitude. Okay, this part, this value is the amplitude. Here also this is, you can say this is also amplitude. Okay, then I told you in the previous class also the different form of EMF equation. E is equal to EM if it is EMF, okay, or voltage, alternating voltage. So E is equal to EM sin theta. EM is the, here EM is the peak, maximum or peak value of the voltage, or it is represented like EM sin omega t. That is EM sin 2 pi ft. Omega t in place of omega we can write 2 pi f. So or you can write EM sin 2 pi. In place of f we can write 1 by t, 1 by time period into t. These are the different form of EMF equation. Next is the what is phase and phase difference. Okay, so what is phase? So by phase of an alternating current is meant the fraction of the time period of that alternating current which has elapsed since the current last passed through the zero position of reference. For example, the phase of current at point A is t by 4 second, where t is the time period, or expressed in terms of angle it is pi by 2 radians. Similarly, the phase of rotating coil at the instant shown in this figure is omega t. It is called its phase angle. See, what is the phase? So for this alternating waveform, alternating current waveform, see here the points are 0, A, and these are the points. We can call it as a 0. This point is pi by 2. This point is pi. This is 3 pi by 2. Then this is 2 pi. Okay. So at 0, its phase is, in terms of angle we can call it as its phase is 0, or in terms of time period, we can also call it as phase is 0. But at see, from this to this, it is one cycle. So here time period is what? T is equal to capital T. So from this to this up to this point, it is what? T by 2. So up to this point, what is this? It is T by 4. Okay. Okay. So at the point A, the phase is, in case of time, it is T by 4. At this point its phase is T by 2. At this point its phase is T. Okay. At this point its phase is 3T by 2. But in angle, if we represent, it's at point A, its phase is pi by 2. At this point its phase is pi. At this point phase is 3 pi by 2. At this point phase is 2 pi. And in case of a rotating coil, its instant, at this instant its phase is the omega t, because it is in this direction and it is making theta angle with the x-axis. So here theta is equal to omega t. So this is also called as phase angle. Okay. So you see in this graph, there is a two alternating waveforms are there. One is A, another one is B. Okay. So we can represent its, from these two we can find out phase difference. Let's see what is this phase difference. Okay. So see, in electrical engineering, we are however more concerned with relative phases or phase difference between two alternating quantity rather than their absolute phases. Okay, so consider two single turn coil of different sizes arranged radially in the same plane and rotating with the same angular velocity in a common magnetic field of uniform intensity. So here two like this is a what, this is a plane. Here magnetic fields are there, then the two coil is present. Okay, rotating in same angular velocity in a common magnetic field of uniform intensity. Okay, so the EMF induced in both the coil will be of the same frequency and of sinusoidal shape, although the value of instantaneous EMF induced would be different. Okay, so however the two alternating EMF would reach their maximum and zero value at the same time. So this is the waveform of this is the alternating voltage waveform of the two different EMFs. Okay, induced EMFs. So what happens? See, their instantaneous value may be different, but their maximum and zero values at the same time there is occurrence of maximum and zero value. Okay, so such alternating voltage or current are said to be in phase with each other. Okay, so these two are called, they are in same phase with each other. How? Both of them have 0 point at the same time, both of them reach their maximum peak at the same time. Again here they both reach 0 at the same time, here also same. Okay, their induced EMF, their instantaneous value may be different, but their appearance, their existence of maximum and zero value are at the same time. Okay, so these two waveforms above, they are said to be in phase with each other in this case. Okay, so the two voltages will have the equation E1 is equal to EM1 sin omega t. Here EM1 is the maximum voltage for this induced EMF equation, and here also E2 is equal to EM2 sin omega t. This represents maximum value. Okay, so what is this phase difference? What is this phase difference? Just do one thing. This is your homework. Study about this phase difference by yourself, and then in the next class I will describe about this phase difference. Okay. Thank you.